Multiplicity and graphing polynomials. If the factored form of a polynomial has any real zeros repeated, then that zero has a multiplicity greater than 1. The number of times a zero shows up in our list of solutions is that zero's multiplicity. This will matter most when we begin graphing polynomial functions. Say we have the fully factored polynomial function f of x equals x minus 3 squared times x minus 1 times x plus 2. This function has a leading coefficient of positive 1 and a degree of 4. Both ends of the graph will have outputs going towards positive infinity. Because x minus 3 is a factor, we will have x equals 3 as a solution. This means it represents an x-intercept on the graph of f. The same goes for x equals 1 and x equals negative 2. X equals 3 has something interesting though, because it has an exponent of 2, the 0 has a multiplicity of 2. The graph of the function will cross through the first two x-intercepts at negative 2 and positive 1 because of the odd multiplicity of 1, but because of the even multiplicity of x equals positive 3, the function will bounce off the x-axis instead. Notice on this example that the multiplicities of the zeros add up to the degree of the polynomial. The multiplicities will always be, at most, the degree. This was an example of graphing a fully factored polynomial function using the end behavior of the graph and multiplicity of each zero. You could extend this knowledge to graphing polynomial functions which are not yet factored and to find an equation from a graph of a polynomial.